All right, guys, welcome to lesson 4.8. I believe this is our last lesson for Unit 4. We're going to talk about a new concept to you guys today called concavity. Concavity basically is the direction a graph is bending. So we'll talk about that in a minute, but for now, just some more details. We're going to talk about what it is in detail, and then after that, we're going to talk about the relationship between concavity and rate of change. There's a little bit of a relationship there. After that, we should be able to know what the concavity of a function is in 3 different ways. One way by looking at a table, one way by looking at a graph, and another way by looking at an equation. So we're going to define concavity, see what it has to do with rate of change, and then determine the concavity of a function in 3 different ways. So that's the plan. All right, so let's go ahead and review slope for a quick second here. Okay, so on this slide here, I've got 5 different lines with 5 different slopes. Okay, and on the bottom I've got some numbers that represent the slopes. So your job is to match. So in other words, draw a line from the number down here to the slope it goes with up here. All right, so see if you guys can pause the video and give that a try, and when you unpause it, we'll discuss it. Okay, let's begin. So first of all, I want you guys to notice something about both of these slopes. They're both negative, and negative slopes go down as you move to the left. So those are the negative slopes. So one of those slopes is the -2 and one of them is the -1/2. Now the way that this works is basically the number that's bigger is going to have a steeper slope. So for instance, -2 is a larger, well, 2 is a bigger number than a half, right? And so because that -2 is more negative than the half, that's going to be the steeper line, whereas the half is going to be the less steep line, but they're both negative, right? And so then we have this line and this line are the positive ones, right? So which one of those is the 2 and which one is the half? Well, since 2 is bigger than half, that means it's going to be more positive. So the 2 goes with that one, and the half goes with that one. And then finally, we have the 0 slope, which of course matches a flat line, which we've talked about before. So the point here being that basically, the steeper a line is, the more extreme its slope is. It's either really positive or it's really negative. And the less extreme that number is, it's maybe kind of negative or kind of positive. So it's kind of going up or kind of going down. And then if it's flat, it looks like that. And just remember, slope is just another word for rate of change. So a positive rate of change versus negative rate of change and all that. Same stuff, just different word really. Okay, let's go ahead and move on to our new topic for today, something called concavity. Concavity talks about the direction an object is bending, okay? So an object can be bending upwards. This would be what we call concave up. Or it could be bending downwards, concave down. Okay? So concave up is like a bowl that's facing upwards to collect water. Raining, the water would fill up the bowl, right? But if it's raining or if you just tilt the bowl over, the water would come out. So that would be concave down. So concave up will collect water, concave down will pour out water, if you want to think of it that way. But there's the idea, bending up versus bending down. So that's what concavity is. Now, well, that's what it looks like. But let's talk about what it has to do with rate of change, because that actually means something. It actually has a meaningful outcome here if we see what it has to do with rates of change. All right, so what is its relationship to rate of change? Well, I'm going to go back to this slide to show you. What if we take these slopes, and as you notice, they're in order from smallest to largest. We start at -2, we go up to -1/2, to 0, to 1/2, to 2. So we're going from low numbers to high numbers. But what if we take all these slopes and we put them together where one leaves off, we cook the other one? Well, what that means is my slopes are increasing, right? We're going from really negative to a little less negative to 0 to kind of positive to really positive slopes. But when you put them all together, what kind of a graph do you get? You get a concave up graph. So when slopes are increasing from left to right, you get concave up. I'm going to write that down here for a second. If slopes increase from left to right, you have a concave up graph. Okay? But let's rearrange them a little bit differently. Okay? So in other words, I'm going to take the biggest slope and I'm going to put it over here. Then the next biggest slope here, then the next biggest slope here. I'm going to reverse their order, so now they're in this order. So I want to go from the biggest slope, which is +2, to the smallest slope, which is -2. So instead of going from smallest to biggest, we're going from biggest to smallest left to right. So let's match these up accordingly. There's my graphs for my slopes. But let's put them together once again. So if I take this and then connect the next slope to it, and then connect the next slope to it, and then the next, and so on, well, what kind of graph do we get then? Surprise! You get a concave down graph. So if slopes decrease from left to right, you have a concave down. Okay? So that's the relationship between concavity and slope. Now, slope is just another word for rate of change, so I could just change this to rate of change, and it means the same thing. I could do that up here too. Because rate of change is just another word for slope, right? So if the rate of change increases from left to right, then it's concave up. And if the rate of change decreases from left to right, you have concave down. And so that's the relationship between rate of change and concavity. Slide here. Right. So I'd like you guys to go ahead and record those two little notes there on this slide where it says, how does concavity relate to rate of change? And we can have that summary right there. So increasing rates of change results in concave up. Decreasing rates in change result in concave down. Okay? Now, before I go on to my next slide, I want to analyze things up a little bit more for you here real quick. So we talked about how this is concave up, and we talked about how this is concave down, right? Well, what I'm about ready to do now is I'm going to break these graphs up into pieces. Okay, so from here to here, it's concave up, and from here to here, it's concave up. But something different is happening in the green area as opposed to the blue area. On the green area, the graph is going downwards as I move to the right. It's decreasing. On the left side of this concave up graph, the graph is decreasing. And what that means is that the rate of change would be negative over here. Whereas on this side over here, the graph is increasing, which means that the rate of change is positive. So This whole graph here is concave up. Let's not forget that, because it's like an upwards facing bowl. But on the right side, the function, the graph, I should say, is decreasing, which means that the rate of change is negative. Whereas on the right side, the graph is decreasing, but the rate, and that means that the rate of change is positive. Okay, so concave up graphs can be decreasing or increasing. Oh, actually, I really just wrote a typo there. This is supposed to say on the right side, the blue side, it's increasing. So concave up functions can be decreasing or increasing, which means they can have a negative rate of change or a positive rate of change depending on which interval you're looking at. And the same thing applies to this pink one over here that I did. Let's take a look at that one really quick. So from here to here, the graph is going up, but then from here to here, it's going down. Okay, and remember, whenever we talk about this stuff, we're always talking about moving from left to right. So I'm going to put little arrows on here so you can imagine which way we're moving. So as I move to the right, this area is increasing, and as I move this way, this area is decreasing. So this whole picture here is concave down. But this half of the picture over here is decreasing. And that means that my rate of change is negative. Whereas on this side over here, my graph is increasing, which means that my rate of change, ROC, rate of change, is positive. Okay? So concave up and concave down can be either decreasing or increasing. And so now the next slide is going to help us kind of break this up in a little bit more of a systematic way. So here it is. Instead of looking at a full bowl, we're looking at half bowls now because it's different on each half. So in this column here, we have the right half of the bowl and the left half of the bowl just split up in two places. Both of these are concave up because they're both bending upwards. But in this case, it's bending upwards and it's also going upwards. It's increasing. It has a positive rate of change. Okay? Here it's decreasing while it's bending upwards. So in this case, you have a decreasing function, but a negative rate of change. Now, the rate of change is still increasing because it's going from really negative to less negative. It's getting flatter, right? The slopes are going from really steep negative lines to less steep negative lines. And so the slope is actually increasing. It's just becoming less negative. Okay, so there's that. Whereas for this one over here, our graph is going up, so we would say that this graph is increasing. But what's happening to its slopes? Well, over here it's got a really steep positive slope, but then it becomes less steep positive and less steep positive. So since the slopes are becoming less steep and positive, then the slopes are actually decreasing in value. Here, the function's decreasing because it's going down, and let's take a look at what's happening with the slopes. Here we have kind of a flat negative slope, but then it gets more negative and more negative. So it's becoming more and more negative, which means that as a number becomes more negative, it becomes smaller, right? So this is a decreasing rate of change. So in both cases, since it's concave down, we have a decreasing rate of change. But in this case, the function itself, the y value, is increasing because it's going up. And in this case, it's decreasing function because it's going down. So there's two things that we're looking at here. I want you guys to pay attention to. We're looking at the function and the rate of change. You could tell if the function's increasing based on which way it's going. Is it going up or down? You can tell if the slope is increasing or decreasing by looking at the concavity. Concave down means the slope is decreasing. Concave up means the slope is either becoming more positive or less negative, or if the slope is decreasing, then it's either becoming less positive and more negative. One of the two situations. All right, that's enough rambling about that. Let's go ahead and put it to practice. This little chart will be helpful for the things that will be coming up in a little bit. All right. Okay, so for this problem here, I'm giving you a function in the form of a equation, and I'm giving you an interval. Once again, when you're dealing with bending functions, you have to look at intervals because it may be doing one thing on one interval, but something else entirely on another. So you always have to say, okay, what part of the graph am I looking at? And the part we're looking at for this is from -2 to +2, right? Now our job is to determine, is this graph concave up or down? All right, well, in order for it to be concave up or down, I would have to look at the slopes. If the slopes are increasing, then it's concave up. If the slopes are decreasing, then it's concave down. Okay, so I need to find a bunch of slopes on this interval. And once I find all those slopes, I just need to see, are the slopes getting bigger or are they getting smaller? All right, so that's our goal. All right, so now I'm going to make a big long table here to work this thing out. And I'm going to number them like steps. So the very first thing that we need to do is let's go ahead and list all of our x values. Okay, so -2, -1, 0, 1, 2. Now, why did I pick all those? Well, I have to start at -2 and I have to stop at +2. Now, I think to get a good answer, you should have at least 5 points. Okay, you can get away with 4, but it's kind of helpful to have at least 5. All right. The next thing we need to do is we need to find the y values for each of those x's. So let's do that. How do we do that? You're going to plug in each x value into the equation that they gave us up here. So I'm going to show my work up here. So you do your powers first. -2 to the 4th power is 16. -2 squared is 4. And 16 minus 32 is -16. So I end up with -16 for that first x value. Now, I'm not going to show my work for all of these just for the sake of time. Hopefully that kind of helps you guys understand how to do it though. But basically, I'm just going to keep doing that. I'm going to plug in the -1, and then I'm going to plug in the 0, and so on, and get all the answers that I can. So if I plugged in -1, I'm going to have I'm going to get -7. If I plug in 0, I'm going to get 0. If I plug in 1, I'm going to get -7 again. And if I plug in 2, I'm going to get -16. Okay? So, if you want to make a little note there, just put plug in x's to get y's. If you don't think you're going to remember that, you might want to write that little note down. Okay? That's basically it. Plug in your x's to get the y's. Now, remember, what am I trying to do? Let's not lose sight. I want to know, is this graph concave up or concave down? And the way that we can know that is by looking at the slopes. So I don't have any slopes yet, so I need to keep going. We're not there yet, okay? So the next thing we need to do is actually start finding some slopes. So I'm going to call this step 3A. Finding a slope is going to be a multi-step thing. So first of all, we want to find how much is the y changing. So in other words, how much did we change here? If I go from -16 to -7, how much did I change? Well, let's find out. -16 minus a -7 is a total of 9. So I went up 9 spaces. How about from here to here? How much did I go up? I went up by 7 spaces. If you go from -7 to 0, you went up 7 spaces. How about here? From 0 to -7. Now in that case, I'm going down, so now I'm going down 7 spaces. And how about here? If I go from -7 to -16, what did I do? I went down by 9 spaces. Now 3a is what we're going to call the delta y. And what delta y means is how much did y change from one point to another. So from point 1 to point 2, it went up 9. From point 2 to point 3, it went up 7. From point 3 to point 4, it went down 7, and then down 9 after that. So that's what we call delta y. Now I'm going to do 3b. 3b is going to be over here, because now I want to find delta x. I want to find how much did the x change. We're going to call this delta x. Okay, so in other words, from here to here, how much did I change? Well, if I'm going from -2 to -1, that means I went up 1 space. How about from here to here? Up 1 space. Now, usually, they'll always be up 1, but they could be different, so depending on what numbers you pick. In this case, all my delta x's are 1. I just went up 1 each time. So let's review where we're at so far. I took the interval they gave me, and I made a list of at least 5 x's. Then I plugged in those x's to find my y's. Step 3, I found my delta y's. How much does y change for each step? And then I found my delta x's. Now we're on to step 4. Now step 4 is where we're going to find the slope. Now slope, something we haven't looked at for a little while, is delta y over delta x. How much does the y change over how much does the x change? Okay, so here we go. My first delta y was 9, right? What was my first delta x? It was 1. So my first slope is going to be 9 over 1. What's my next slope going to be? 7 over 1. My next delta y was 7, and my next delta x was 1. So delta y over delta x is my slope, and that's 7 over 1. All right, what's the next one going to be? -7 over 1. And then finally, -9 over 1 is the last one. Now, sometimes you're going to have fractions here, you guys. And when you do, I say just get out a calculator and change them into decimals. It'll make things a lot easier. But in this case, all my denominators are 1, so it's pretty simple. To simplify it, I'm just going to do this. All right. So now we're going to move on to the next step here. So I've got my slopes. Remember, what's my question? My question was, is this graph concave up or concave down? To do that, we need to look at our slopes. Okay? And so what's going on with my slopes? Are my slopes getting bigger or smaller as I go down here? Are the slopes increasing or decreasing? Well, if I'm starting at 9 and ending up at -9, I'm decreasing. Weird way to write that, isn't it? But we're decreasing. And what did we say about that? Well, let's take a look. I'll bring that back in a second. Let's back up a little bit. When we were on this slide, what did we write down? We wrote down that if the rate of change, which is also known as the slopes, if the slopes are decreasing, then the graph must be concave down. So there's our final answer there. Step 6 is to decide, is it concave down or concave up? And in this case, the answer is concave down. for down. So it's concave down because the slopes are decreasing. So I've got a 5-step process here for you guys, a 6-step process actually. Step 1, pick some x values from the interval that they give you. Step 2, plug in those x values to get the y values. Step 3a, find your delta y's. Step 3b, find your delta x's. Step 4, make a fraction out of your deltas, delta y over delta x. If necessary, use a calculator to change them into a decimal. Step 5, ask yourself, are those slopes increasing or decreasing? Since they're decreasing, you could decide it's concave down. If we had gotten increasing slope, then we would say that this graph would be concave up. So there you have it. There you have it. Now, once again, technology is a great way to check your work. I could just go on to desmos.com. You could graph the function x to the 4th minus x squared and look where it starts at x equals -2 to x equals +2. And you could see that this whole graph from here to here is concave down. Okay? Now, something I'm not going to trouble you guys with too much is it probably actually stops being concave down, probably right about there and there. But I'm not too worried about it for now. So long as your table matches the outcome, we're good to go. All right. So here's one for you guys. In retrospect, I wish we could have done a guided practice. So why don't we treat this one kind of like a guided practice, and then we'll do one more after that. You guys do it completely on your own. Okay, so step 1 was to pick some x values. And just to kind of make things a little bit more interesting, let's see. I think I'm going to have you guys pick some other x values. So let's go from 1 to 5. Let's do that. So I'm going to change your interval a little bit. And I want you guys to go ahead and do step 1 for me. Go ahead and pause the video here and do step 1. And when you unpause it, I'll show you the answer. So basically here, guys, step 1 is just to list your x values. So you start at 1 and you stop at 5. And you want to have, I would say, at least 5 points. Like I said, you can get away with 4, but you get more information, a little more help if you have 5. All right, let's go ahead and move on to the second step. So go ahead and pause the video here and do your second step. So your second step is to find the y values by plugging each one of these x values into this equation that we have here. Now I'm going to start by plugging in the bottom one first. I'm going to plug in 5. Now you do the parentheses first and you get 4, then you square it to get 16, and then you multiply to get 32. So we're going to put -32 right here, and you're going to keep that process up for the rest of them. All right, now we're ready for step 3. Now 3 comes in 2 parts. We're going to do 3a, and we're also going to do 3b. Okay, so go ahead and pause the video here and do steps 3a and 3b. Well, step 3a and 3b was to find your delta y and delta x. So delta y, starting at the top, we go from 0 to 2 is down 2, and then from -2 to -8 is -6, and so on, and you get all these values. Then you find delta x on this side, which is, I'm going up 1 every time, so I put pluses. Don't forget, you have to include the sign there, whether it's positive or negative. All right, let's go ahead and move on to step 4. So go ahead and pause the video here and do step 4. Step 4 was to find the slopes, delta y over delta x. You take each delta y and you put it over each delta x. So take -2 over 1, -6 over 1, -10 over 1, -14 over 1, etc. And you reduce or change into decimals if necessary, and then you just look at the numbers. So I'm going from -2 to -6 to -10 to -14. So what's happening to my slopes? Well, you might be tempted to say they're getting bigger. Remember, these are negative slopes. So they're actually getting more negative, which means the slopes are decreasing. And so step 5 is where you decide whether or not the slopes are increasing or decreasing. And in this case, the slopes are decreasing. And then finally, step 6, what would our conclusion be then? If the slopes are decreasing, is this graph concave up or down? And the answer is it's concave down. I'm just going to put C down. Okay? So that's a guided practice. Let's do one more where this one's going to be a student practice, and you can just do it completely on your own. This time, I'm going to pick the x values for you, and you're going to end up with some slopes that are fractions, okay? They're not going to be like over 1 anymore. And because of that, you're going to need to do dividing the top number by the bottom number and changing it into a decimal in order to figure out the answer, okay? So let's go ahead and get you one to try. All right, so there you go. I picked some x values there for you guys. I'd like you to use those ones. Go ahead and pause the video here and do all 6 steps and see if you can decide whether this function is concave up or down on the interval provided. So if we have these, I thought we'd get decimal. I tried to get it, didn't work out, but oh well. Makes it easier anyway. Here's the x values, here's the y values that you get by plugging it in. Here's your delta y's, here's your delta x's, and then whenever you make your fractions, you have 24 over 2. Now that one needs to be simplified, and you get 12. And then your next slope would be negative 6 over 1, followed by negative 10 over 1. And so as you can tell, your slopes are decreasing. You go from a positive 12 to a negative 6 to a negative 10. So slopes are decreasing, and once again, it's concave down. It's kind of unfortunate that every example I've picked so far has been concave down. Just understand that if your slopes are ever increasing, that would actually mean that it's concave up. So make sure you pay close attention to that. But anyway, that ends that whole talk. We have one more thing I want to do for you today, and for this last bit, you're going to find this chart particularly helpful, so you might want to come back to that for this next set. So last class we did some sketching where we put functions with certain slopes on a graph, right? But today we're going to do the same thing, but we're going to add some concavity to the mix. So for example, I'm going to be going from negative 3 to negative 1, and then from negative 1 to 2, and then from 2 to 4, and 4 to 6. But as I do those things, we're going to be making sure that our graph does the things that they're listing there. So let's go ahead and start from the beginning, where I like to start by listing or drawing out a graph with those intervals highlighted, just like I did last time. So here we go. We're going to draw an x and y axis. We're going to start with x equals negative 3 on the left. And then it goes to negative 1. So from negative 3 to negative 1. And then we go from negative 1 to positive 2. So now I'm going to put another mark there at 2. And then we go from 2 to 4. So I'm going to go up to 4 now. 3 to 4. And then the last interval goes from 4 to 6. So 4 to 6. So I've got all my x values listed, and as you guys know, I kind of like to go through and just highlight those intervals really quick. So from negative 3 to 1, from 1 to 2, 2 to 4, and then 4 to 6. So I like to highlight those just so that my brain knows where to start and stop when I move on to the next step. Okay. All right, so now let's take a look at our first interval there, which I'll do in red. What's it saying about from negative 3 to 1? Well, we want it to be concave up and increasing. Okay. So in order to see what that looks like, we're going to go and we're going to look back on that one slide that we had before. So let's go ahead and go back to that slide really quick, right here. So I'm looking for where is it concave up and what was it? It was concave up and increasing, I believe, right? Concave up and increasing, yes. So let's find concave up. Here's concave up, right? So we're in this column. It's got to be one of those two. Concave up and increasing. Now, you can ignore this part because if I tell you concave up, that's what that means. Increasing rate of change just means concave up. So we can ignore that. They're not talking about this when they say increasing. When the instructions say that the function is increasing, they're talking about this. So increasing versus decreasing. So we're looking for a concave up function that is increasing. And as you can see, that's going to be this one right here. So that's the shape that we need on that interval. Concave up and increasing. So let's go ahead and we're going to go back now to this slide. And now I know that on the interval from -1 to 3. I'm going to take that shape that I just saw and I'm going to draw that. It's going to be bending. I don't like how I'm drawing. I'm going to draw it a little bit. That was technically okay, but there we go. There's the shape. It's concave up and it's increasing. So it's going up and the bowl is facing upwards. Now the next one says constant. So from -1 to 2, it's just going to be a straight line. Straight line. All right, now how about number 3? Now at number 3, we're looking at concave down and decreasing. So we want concave down. Oh, I said decreasing, I'm sorry. Concave down and increasing. So back to our little chart there for a second. We want concave down and increasing. So concave down is in this column. So it's one of those two shapes. Second of all, we want it to be an increasing function, so it's going to be this one. Okay, so that's the shape that we're looking for there. So let's go back and we're going to add that shape now to our graph. So from 2 to 4, it's concave down and increasing. That would look like this, right, if we draw that graph. Concave down and increasing. And then the last thing we're going to do is we're going to do from interval from 4 to 6, and that's concave down decreasing. So once again, we're going to go back to our chart here. We're going to find where concave down is. So we know it's one of these two here, and it's decreasing, so it's that one. So we're going to go ahead and just put that shape on the last interval, and we'll be good to go. Now we've got our graph drawn. Concave up increasing, constant, concave down increasing, concave down decreasing on the intervals that they gave us. Okay? So now I'm going to give you guys a picture, and it's going to be kind of similar, but instead of sketching it, I'm going to have you describe it. Okay? So I've given you a graph here, and I want you to tell me on which of these intervals is the function decreasing. Now that means on which interval is the graph going down? That's what that means. The graph goes down. If the function is decreasing, that means the graph is actually going in a downward direction as we move to the right. On what interval is the rate of change decreasing? Now, if you have a rate of change that's decreasing, I want to remind you that means that your graph is going to be concave down. So it means the same thing as concave down. So on what interval is the graph concave down? That's the same thing as saying the rate of change is decreasing. And then finally, on which interval is the function increasing? So in other words, the graph is going up. The graph goes up, but it's also concave up. So I'm going to let you guys see if you guys can identify these intervals correctly. Go ahead and pause the video here. Now, how do you write an interval? Like, let's just say, for instance, that you wanted to talk about this interval from here to here. Well, all you do is you take the D, and you take the E, and you just put. You could write your interval like this, as we mentioned before, in brackets, or you can write it as an inequality where you're saying x is between those things. But it doesn't really matter how you choose to write your interval. But basically, that's how your answer will look for each of these. You'll have two letters describing where that interval starts and where that interval stops with that particular quality. So once again, go ahead and pause the video here and see what you guys can do. Okay, so for number 1, on what interval is the function decreasing? And as I told you, that means the graph is going downwards in a downwards direction. And so one place that's happening is here. The graph is decreasing here. I don't see it decreasing anywhere else. So that starts at A and it ends at C. And so your interval for this one would be from A to C. Now you can write it like this, Or you can write it like this. It doesn't matter. Okay, but there's our answer for number 1. Let's go ahead and take a look at number 2. Now, number 2, I asked you on what interval is the rate of change decreasing? And as I clarified for you, what that means is that if the rate of change is decreasing, that's just the definition of what concave down is. So where is our graph concave down? Well, that would be right here. That's a concave down piece right there. So for that one, we would say that the interval is from B to E. You can write your interval like that, or you could write your interval like this. Either way is fine. All right, let's go ahead and take a look at number 3, the last problem there. On what interval is the function increasing and concave up? So where is it going up and concave up? That would be here. It's concave up. You can see the bowl shape, like it's facing upwards. But the graph is also going up as we move to the right. And so that would be our concave up region. So that pink area there, that would be the region where it's concave up and increasing. So we're saying from C to D, or you can write it once again as an inequality. Okay, so there's our answer for that. And that closes out that particular lesson. And we'll see you guys next time.